Right, so let's look at how we can identify redox reactions. So we're confronted here with a question that says which one of these or which of the following represents a redox reaction. We're given two reactions. Explain by referring to the oxidation number of the atoms in the participating species. So our first step is to assign oxidation numbers. So oxygen is -2, iron here is +2, oxygen here is -2, carbon here is +2. Iron on its own has to have a 0. So in other words, now it's a pure species, so it has to have an oxidation number of 0. And oxygen will still have an oxidation number of -2 as long as it's not bonded with only hydrogen in a peroxide fashion. And this means the carbon has to have one of +4. So it means the iron goes from +2 to 0. It is reduced because it gains electrons, and the carbon gives off electrons or forms more bonds with oxygen, hence it is oxidized. So yes, you can write it as in A, you say for iron, its oxidation, it goes from +2 to 0, and carbon goes from +2 to +4. So therefore, this one is reduced, and this one is oxidized. And of course, you're answering the question, you write it neatly, and you say, the oxidation number of iron decreases, and hence it is being reduced. The oxidation number of carbon increases, hence it is oxidized. So yes. So from this, therefore, yes, it is a redox reaction. All right. I'm of course just not writing everything because then the video becomes very long to convey a simple concept. The second one, so let's look at what happens here. So it says FeCO3 becomes FeO CO2. So again, I mean, oxygen is -2, so that's -6 carbon and iron. So now in this case, you have to ask yourself, how would FeCO3 look? What is this compound? And it is actually, if you think about it, it's Fe2 plus carbonate, so it's CO3 2 minus. So that carbon then has a charge of +4 because you look at the carbonate anion. So and iron has to have a 2 plus. So you know that. In this case, we have oxygen -2, iron will be +2. In this case, oxygen -2 and carbon +4. So is there any change? No. So therefore, because there's no change in oxidation number of Fe or carbon, therefore it's not a redox reaction. Okay. So that's essentially it. If there's change in oxidation number, then it means it's a redox reaction. If there's no change in oxidation number, then it's not a redox reaction. And this is quite a good example of where you don't just use your knowledge of looking at the species, you also use your knowledge of iron. So you know that's Fe2 plus and CO3 2 minus, and then you get the oxidative states of those species. Okay, so don't be blind to that. Don't, if you're assigning oxidation numbers, look at them individually. Still remember that there's normally a cation and an anion in a salt, because FeCO3 is a salt. It is some form of anion, cation, ionic salt that forms. Okay, that's what I wanted to do here. I hope this was quick enough. But anyway, thank you for watching.